Thanks for having me. I appreciate being able to participate in this. I know that a lot of you out there are into robotics. You've been working with robotics. I know there's some parents out there, I am here to sort of talk to you a little bit about what I do at Illinois Tech as a professor, but I'm going to save that to the end and talk about the more pressing issues in robotics, and that is trying to give you guys some strategies to feature future robot overlords. All right, so we're going to see what we need to do. All right, I usually start off with all my talks, no matter where I go, as a little shout out to Illinois Tech, who we are and where we are. You may have gotten some of this information elsewhere, but that's okay. I'm going to give it to you again. We're a small private PhD granting institution on the south side of Chicago. This is a picture from our tower overlooking our campus. Our campus is actually very famous for architects. A lot of architect nerds come by and visit our campus because it was designed by Mies van der Rohe, who was a very famous architect. And you can see us just on the south side of downtown Chicago, right there. Okay, so the first question I'm going to ask here is, what is a robot? And I'm sure a lot of you are, a lot of you know what a robot is. I would guess that most people can't actually articulate it. It's hard when you ask somebody to define a word. That's something that's really hard to do, actually. And there may be some other people out there who don't kind of know what a robot is, or they have a feeling for what it is, but we're not really sure. So I'm going to start off here, and I'm going to look at a couple different definitions of robots. And the first one that I have is I just found these online, Oxford Dictionary, online dictionary here. And the first one is a machine capable of carrying out a complex series of actions automatically. So I'm going to just play a little video right here, and we'll see what we can do here. And I would argue that this is a machine that is carrying out a complex series of actions. We've got all these, it's creating a rope, right? And so it's binding all this rope together, and we can sort of watch that again. Sometimes when I ask people and I get some feedback, how many people think this is a robot? A lot of people raise their hands. They think this is a robot. I'm going to disagree. I don't think this is actually a robot. I think this is doing something over and over again. It's automatic. It is doing a complex series of tasks, but there's something about that just says, hey, that's not really a robot to me. All right?
Ja, 20 Minuten lange Videos.
Okay. So, all right. So I'm getting a little bit of feedback there, but I'm going to keep going. I can't really hear it, so we'll just kind of keep moving along. This is another example right here. So this is a definition, again, from the internet: a machine that operates automatically with human-like skill. So I always start off with what human-like skill is. This is the first clip here is a clip from I Love Lucy. It's a famous TV show from like the 1950s in America. And this is one of the famous scenes where Lucy and her friend Ethel are working in a chocolate factory. And we won't watch the whole thing. It's actually very, very funny. But we'll just watch a little part of it right now. And it looks like my sound isn't coming through, but that's okay. Basically, the instructor's telling her, hey, it's time to we're gonna work on this chocolate factory. All right. So Lucy and Ethel are moving along, and they're wrapping up the chocolates in the chocolate factory. And as you can imagine here, in any sitcom, it's not going to go quite well for them. Things are going to speed up. I'm gonna speed it up a little bit here. I'll skip ahead as they're moving along here. And of course, all of a sudden, they can't actually keep up, right? And this is a very common robotic operation. This is a pick and place operation. So there's a lot of robots out there who do these types of operations. All right. So obviously, okay, they're not gonna make it, and they end up going too far, right? Okay. Now I'm gonna show you another video here from a modern robot. This is called a parallel link manipulator. And these are designed for pick and place operations. And we'll show it here. I'll get it. Here we go. So this is a guy, this is a robot who's doing the same thing. It's picking up pancakes in this case. Nothing like delicious industrial made pancakes. You might feel different next time you go to the store and buy some pancakes, knowing that this is how it's done. But look at how fast this thing is moving. And this isn't even top speed for these types of machines. These machines can actually move much, much faster. It doesn't need to, obviously, in this case. But I'm arguing here that this is a machine that's operating with something that far surpasses human-like skill. It's much, much better than human-like skill. So I don't like this definition either, all right? All right, so next definition we have, here we go. All right, this is from dictionary.com, and this is a machine that resembles a human and does mechanical routine tasks on command. So I'm going to show you this video from Boston Dynamics. Probably, I'm going to guess there's a large number of you who have seen some videos from Boston Dynamics. Boston Dynamics is a company that is definitely at the forefront of mobile robots, and they have been for many, many years, for decades. And they specialize in legged robots. So they're a lot of fun to watch. And again, here, the sound doesn't seem to be coming through, but we'll see. If it does, you can see Mick Jagger on the left and the Rolling Stones. And you've got one of their quadruped, that's a four-legged robot on the right that is dancing along with Mick and the rest of the Stones here. I'm going to argue here that that is definitely a robot, and it's definitely not doing any sort of routine task on command. It is executing a series of complex behaviors. It's interacting with its environment, and it is responding to feedback in the environment. So my definition of a robot is, I forgot, I got to throw this one more in because I'm going to show this a little bit later. Plus, it's just really, really cool, and it's the state of the art. So we'll show this is Atlas robot. This is a bipedal robot. So this is one that resembles a human. And here it is doing a series of parkour moves. I doubt you have American Ninja Warrior, but it's a very popular TV show on America, and it has sort of a lot of these types of obstacles in it that humans run around doing. And so here we have the system with the bipedal robots doing this. And we're going to come back to this video later on in this talk because I want to sort of give you some ideas again how to feature robot overlords by studying what Atlas is actually doing here. I mean, that stuff's incredible. You know, I've been doing this for 25 years now, and the fact that this stuff is coming out is just really, really impressive. All right, so what is a robot? So I say robot is a machine because I think it does have to be a machine. It can't be a simulation or a computer program. Some people think those are robots. I don't. I think that it actually is a physical machine that moves and interacts with its environment. So it's not just like an HVAC system that runs your air conditioning and heating in a house, because that's a machine, but it doesn't move, and that's not a robot. So it's got to move, it's got to interact with its environment such that the machine changes its behavior based upon sensory feedback. So it's got to have some idea of sensing its environment, and then changing what it does based on it. Now, those can be two different types of sensors. We have what are referred to as external sensors, probably what you think about, vision sensors, LiDARs, radars, sonars, all those types of things, that contact sensors that go out and physically interact with the environment, whether that's photons coming in or touching the environment. And then the robots also have proprioceptive sensors. So things like what you have in your inner ear to help you balance, robots have the same thing with accelerometers and gyroscopes, inertial navigation systems that allow it to balance, let's say, and understand where it is inside itself. All right. So what can robots currently do? All right. So here's a video, another video I have from 1960s, I think. This is a factory, a Ford factory from 1960s. I love this video. So take a look at just how many people are in this factory. All right. We've got people moving large pieces. We've got people spot welding. These are spot welding operations. These are all done by humans. More spot welding. We'll see some deburring coming up here soon. So they're going to be doing, all right, so just moving everything in, so much welding. Here's some soldering and brazing operations happening, more welding operations. Here's the soldering and brazing operations. All right, so really just a lot of stuff. Now we're gonna, let's see, there's another guy, oh yeah, painting. Okay, again, all done by humans. One other thing, let's see if it's coming up. There's some inspector coming up and moving it on. So just sort of give you an idea, this was, 50 years ago, maybe 60 years ago or so. I'm not sure if this was in the 60s or 70s, but this was pretty much the operations and through the 80s. And now I want to show you what happens now, which is a Porsche Taycan factory. Could have showed you the Teslas, but I like the Porsches. So we're going to watch the Porsches move through this operation. There are still humans around, but not so many. All right. These guys are doing a lot of finishing operations. Let me see if I can get you to, oh yeah, let's move it back here and let's just get to some of the basic. Here's, you have these huge manipulator arms. All the spot welding, all that we saw before, all is done by robots now. Perfectly, there's really very little human interaction until you get to sort of the general assembly stuff. All right, this is sort of starting to assemble stuff, doing some of the more intricate things that the robots can't do. And it really speaks to sort of saying just how much robots have permeated manufacturing, and obviously high-end manufacturing like cars, but also some other manufacturing as well, general manufacturing. All right, so that's one example here. The other example I have is of Amazon warehouses, and these things are amazing. They, I don't know if anybody has worked in a warehouse. I used to work in a warehouse when I was in high school, and it's not the best job. Maybe you work in the, like, I didn't enjoy it so much. So it's one of the reasons I went into engineering. But I have, let's take a look here on what Amazon does, which is very different from how I worked in a warehouse. I used to go around and take stuff off of stacks. All right. So what we have here is the Kiva system. All right. So this system right here, these are robots and they're moving stacks, they're moving products to humans that are literally standing in place. And so they're able to jam so much more into a facility. All right. So they have these giant facilities and they can pack them so much more because they have these robots that are programmed. And all they have to do is, all the humans do is either put products into the stacks to then go into the warehouse or take the products off the stacks. Now, if you ask Amazon, or let's take a look here. Let's see if we can see what some of the humans are doing. later on. We'll watch these guys. We'll see maybe some of the humans later on doing some operations. Let's go back to, yeah, let's see. So here are the humans going through the not too much stack. So basically, yeah, here's an operation. Here's a stack. They see them. Sorry, it cut off again. And they're pulling these off the stacks, doing these sort of last minute operations. Now, if you ask Amazon, which I had one chance to do to talk to the CTO of Amazon a long time ago, and you ask them, you said, now, is Amazon trying to remove jobs? And they will not say that. They will say every place that Amazon goes to, we increase the number of jobs, right? And that's probably true. Oh, here's a good example. A person standing in one place and just pulling this stuff off the stack. But Amazon also sponsors what's termed the Amazon Pick and Place Challenge. So this is where a lot of universities were part of this challenge for maybe 4 or 5 years or so. And their task, as you can imagine, is to create robots that pick stuff off. Basically doing one of the few jobs that Amazon is hiring for today. Now you can see they're not that great. And this operation here, you look down. Every time you see a robotics video, you got to see, you know, look down and see the times 15. This means that this is operating at 15 times its speed, actual speed. So yeah, it's doing the job, but I think the best these robots got were around like 120 picks per hour, where human operations get up to like 500 or 600 picks per hour. So still a far way away, but people are working on that. A lot. It's putting a lot of money into these efforts, these companies are. All right, so what happens when the robots leave the factory and start coming for me? I'm sure you guys were all very concerned about this. So when the robots get their lasers and they start coming after us, what do we need to do? All right. So we have two options. The first option is that we're going to fight, and I'm going to show you what you need to do in order to fight. So the first hint here is that almost all of the videos you see on the web are videos of only the robots doing the job successfully. So here's Atlas doing the same thing that it was doing before, but failing every single time that it does it. And I'm actually really impressed that Boston Dynamics put this video up on the web. The next one here, these videos come from the DARPA Robotics Challenge, which was probably it's about 4 years ago right now. But still, other than Boston Dynamics, who did supply a number of the robots for this competition, this is pretty close, still pretty close to the state of the art of what's out there. So so if you do want to fight, one of the first options you have is to simply walk away, because simply walking is extremely difficult for a lot of these robots. Here's one trying to get over some rough terrain. You saw one in the beginning try to get over here's someone trying to get over the sand, not doing the greatest job at it. All right. All right, so that's option number one. You can walk away. Step number two you can take for fighting back is taking the stairs. This guy is trying to make it up the stairs. It took him, I think, 8 minutes. Basically stood in this one position for 8 minutes. And then I'm going to have to skip ahead a lot here. All right, it's slowly, I'm skipping ahead minutes here. It's slowly making its way. So hopefully by this time you're already on like the 3rd floor or the 4th floor of the building. And it's getting up there. I gotta move. I gotta skip ahead some more. All right, it's gonna finally take its first step soon. And wait for it. And no, not so quite. Didn't quite do it. All right, so you can take the stairs, all right? Third option, all you have to do is plan the revolution behind closed doors, all right? So I don't know if you ever saw the original Terminator back from 1983 or 84, and all the revolutionaries were behind the door, and knock knock, the Terminator comes to the door. Well, in reality, and he comes in and wreaks havoc, but in reality, these robots have, we saw this one already, these robots have a really, really difficult time just making it through a door. I think that one's my favorite. It gives up with flair. It fails with some flair. This guy kind of just quits on you over here. All right, so that's pretty close. Again, that's about 4 or 5 years old now, but it's pretty close to the end of to state of the art. The other popular thing to do with robots, especially these legged robots, is to harass them. So here we have systems that we're going to start kicking. All right, and so it's a very popular thing to do because it really shows off how well these things balance. There you go, it's a nice big kick. But I think there is some worry that once the robots become sentient, they're going to watch all these old YouTube videos and see how badly we harass them. So maybe we don't want to do that too much too often. All right, option number 2, you could fight or you can accept your fate. This is Ken Jennings, who is a Jeopardy champion. Jeopardy is a famous trivia show in the United States, and Ken Jennings was one of the biggest winners, and he played against IBM's Watson, which is basically their artificial intelligence, and he lost in the end. He lost in the final, but in his final answer, he wrote, "I, for one, welcome our new computer overlord." So Ken accepted his fate, and he can, sit back, kick back a little bit, and just sort of watch the robots do the work. So, we can fight it as much as we want, or we can realize that these guys are going to be out in the warehouses, perhaps in our homes, doing a lot of the heavy lifting for us. So perhaps we can. All right, so hopefully you guys have some options on what to do when the robots start coming for you. I've got a few minutes left. I've got about 6 minutes left. And I want to sort of cap it off with some of the things that I do in my lab. So we have a research lab, mostly PhD students, a couple master's students, and a number of undergraduates who volunteer or even get funded throughout the year working in the lab. We've done a lot of different things. These are some examples of some climbing robots. This is the one on the left is we did in collaboration with NASA's Jet Propulsion Laboratory. This one uses gecko-like adhesives and electrostatic adhesives to climb up walls at different surfaces. So that's the glass and a wood and a drywall surface. So you can see that guy climbing up there. The other one we'll see here. This is the same thing. It's a gripper. Oh, yeah, it's a gripper that's made of gecko-like adhesive. So you can see here that he's actually pressing down the gripper here, and it's not adhesive. But then you can, for a split second, and it may not come through in the video here, but he engages the pads of the gecko or the gripper. They're actually squeezed outward. And what's really cool about this adhesive is that it is controllable. So we can turn the adhesive on and off. It's not adhesive there. We apply a shear load to it, and all of a sudden we have adhesive in the normal direction. So orthogonal to this glass plate right here. And then we have one of our latest robots, and we'll show a number of videos from this. This is a soft robot. It is a soft robot that's based upon what we term a boundary constrained granular swarm, which I'm sure you guys are thinking, what the heck is all that? Basically what it is think of maybe the best way to describe it is if you think of a bag of coffee grounds that you can buy in a store. If it's vacuum packed, that those coffee grounds are rigid, right? That whole thing feels like a brick. But if you release that vacuum, it allows the coffee grounds to flow like a fluid. And that's what we've done here. We basically said, all right, what happens if we take that bag and we put a whole bunch of mobile robots on that bag? We move it around. What can we do? Well, what we can do is something like this, where we're pulling. We actually, you can sort of see here in the middle that square shape. What we did is we grabbed this object and then we created a vacuum. We sucked it in, and then we're pulling ourselves out after we sort of grabbed onto this object here. So it allows us to create this really compliant object, really compliant robot. All right, and essentially a soft robot, and then grab stuff, interact with the environment in a forceful way. This is the same thing. I'll skip it ahead a little bit here, but this is the same thing here where we're pulling on this object, but we're pulling without creating that vacuum seal, right? We're not creating that vacuum seal. So here we're not going to be able to actually pull with as much force. All right. So we can do a lot of other cool stuff with this robot here. Let's see the next video. I think a couple more. I think I have a couple more minutes. And so here's where we're going to be grasping and moving around some objects. So let's move it ahead. So he's kind of moving forward here, and we can track this object. So right now this is being done with an external tracker. We've got a camera on top, not just for the video, but also to help us identify where all these parts of the robot are. We're working on it right now to essentially remove that camera. And so this system could do everything by itself with only sensors that are on the body of the robot. All right, so he's going to go around, he's going to grasp this object, he's going to move it through. And then I'll show you one more video here. This is a shape formation, just to show you how we can take this soft robot and just move it to different shapes, right? We can create circles, triangles, the C shapes. This is sort of a little line right here. And so you really have this really, conformable robot moves around like that. All right. I think I'm out of time here. We do other stuff in our lab, but this is some of the latest stuff and the stuff that I'm really excited about. And if I have a time for questions, I guess I'll take it. If not, I understand. And good luck to everybody in this organization. I know there's some competitions there involved, and I hope you enjoy it. And I hope you look to doing robotics or similar STEM type subjects in the future.
Dear Dr. Spenko, thank you very much. It was so interesting to listen to you. Klaus, what do you think about this?
I thought it was amazing. I know this title for the lecture just caught my attention instantly. I'm from 1974. I grew up with Terminator movies, and of course the first thought I had was, I have to listen to this, because I've been fearing, that the Terminators would come and take over us when I was younger, when I was a kid, and of course, working with robotics, I can see the development and what's going on. It's just phenomenal, and it's like exponential. And so my question to you, Dr. Spenko, is, how can we avoid a Terminator scenario coming around? I mean, we need to teach ethics in coding and robotics, don't we?
Yes. First of all, I hope this is everybody takes this as tongue-in-cheek. I really don't think we're going to come into a Terminator or Matrix-like situation. But yes, ethics not only in coding, ethics in all engineering and science is extremely important. Any place that you go, any institution that these young students are going to go to, we'll be teaching them about that and how to practice that. As anybody in STEM is going to realize that this is extremely important to the profession.
So, if you have one advice for WRO about ethics and how we can bring that into the competitions, what would that be? What should we consider? Is there sort of a
I wouldn't say that the students need to think about that in the engineering so much. I think if they practice that in the competition parts of things, I think that's good. That's great. Mm-hmm. And as you get down into engineering, and you'll realize there's lots of case studies when you develop stuff and you put stuff out to market. That really is what's issue. It's when you put it out there and you have faith, and you need to know that you're doing a good job. Yeah. You have to actually literally do a good job legally. You legally have to do a good job, and it's important. But for the competition, for the students, have ethics in the competition, and then you're going to be on the right track.
That sounds good, because we did introduce an ethics policy, or guides to the young students about how to behave, how to compete, on a fair way with their friends, and make friends across cultures. So I think we're on the right track. So thank you so much, and thank you for coming around for this. It's been really inspiring.
Thanks for the invitation. Good luck to everybody out there.
Good night, and tell everybody watching WRO for the next days. We are expecting a lot of spectators and a lot of new fans. So thank you very much, and bye-bye.